lots of graphene. And when I say lots, I mean tonnage. I had to go out of the country, I had to do this, I had to do that, do some talks, do some this and doing that. So it is what it is. But I have something that everyone's going to be excited about. So this is a typical Panasonic 1800 milliamp hour cell, lithium, and this came from a company that we deal with. And we had already gotten some 50-50 cells, where instead of in lithium-ion batteries, if you know if I remember right, one side is going to be an activated carbon, and then the other side is going to be the electrolyte with a graphite mixture, usually, or another activated carbon type material. But the one activated carbon is a paper type material, and then the other side is a powder form mixed with the electrolyte. In this case, it is a graphite type material. It's an 1800 milliamp hour Panasonic style cell. And I say Panasonic style because actually these get supplied to Panasonic. You can find them on eBay for $4 a piece or something like that. But this is where the fun comes in. This, I haven't even opened this thing yet. That is a real live, the real 100% graphene cell. It's mostly single layer material that is integrated with the electrolyte. I already know some of the data on the 50-50. The 50-50s, okay, where we put 50% graphene and 50% graphite in the material, the 1800 milliamp hour cell went to 3180 milliamp hours, if I remember right. That's what they were averaging. And by that, I mean averaging. They were very, very close over and over and over again. This cell should be in the 36 to 3800 milliamp hour category. I haven't tested it yet, and we're redoing some of the tests as well because we have found, ironically, in our tests that there was a little bit of iron, and if you get up past 6 parts per million in iron, and our raw graphite had a little bit right around there, it will cause a little bit of shorting. Well, self-discharge actually is what it does, and it doesn't really lend well to batteries. But now we've figured out, we've gotten the iron situation ironed out, and so these cells are on the way. Basically, we're talking, we haven't done enough data, but it should be between 36 and 3800 should be the rating. They take a tremendous amount of juice in and out. Their discharge and recharge capacity abilities are far beyond what these are. We're talking seconds to minutes. The 50-50s were our potentiostat. The little potentiostat down there. We actually couldn't even charge and discharge it fast enough to get good readings. The battery was more capable of retaining it. I think it's they're called C's. If you're a battery person, you hear me stammering and being an idiot, you'll know some of these words. They say a C, which is some kind of it's not coulombs, like not the same thing, but the batteries normally will take a like 1 or 0.8 or something like that, and our graphene ones can take well into 6 and 7. And it was actually the engineers were joking and saying they were laughing at 2 or 3, and now they're seeing 6 or 7 going in and out. It's pretty remarkable. This one is a 50-50, and this is 100% graphene. So this is the last day of the Graphene Expo in Xi'an, China. It's pretty big. I'm going to just kind of do a walkthrough. even though there's no, I don't have any stabilization, so, you know, you guys are going to hate me and think that this is a roller coaster ride. But you can see, I mean, there's a heat film. That's we have some information about that. There's some batteries. Here you go. You guys want to see some graphene batteries? RGO. And remember, my batteries that I have in the gun are 2400 or 2800 milliamp hours. And these ones are 1600. So why would you even put RGO in a battery? They have the little... But the thing is, they charge quick. Just like the ones that I have. So, it's kind of neat. Heating films. That company makes a heating film that lasts about a year because it oxidizes. It doesn't even use graphene. It uses carbon black and graphite. Trust me, we've taken everybody's stuff apart. We'll be nice, cooperate, help them out, because in the end, that's a business ethics thing. You would rather sell to everyone than just try to be exclusive to yourself and then sell to nobody. So, you know.